Right, guys, let's look at quadratic equations. Quadratic equations have a very different approach to linear equations. Remember that with linear, there's only x's, and with linear, you get your x's to one side and your numbers to the other side. Quadratic equations are going to be very different. Our basic approach to quadratic equations is get everything to one side and get equal to 0 on the other side. Then we're going to factorize, and then we're going to ask ourselves, if you have two factors multiplied together to give you 0, how can that possibly happen? How could you have two things multiplied together to give you 0 unless one of those factors must be 0? And that's how you get two answers in quadratic equations. Sometimes the answers are the same thing, but you get two answers in quadratic equations always, because you're multiplying two factors together, so one of them has to be 0. But this logic only works if you've got equal to 0. As soon as you have two factors multiplied to give you 6, well, then your factors could be anything. I can have 1 times 6 gives me 6. I can have 3 times 2 gives me 6. I can have a half times 12 gives me 6. So the most important thing is you have to get it equal to 0, because the only two things multiplied together to give you 0, one of them has to be 0. So that's very important. So let's look at some examples. The first example, I've deliberately used one that's already factorized. Please don't go multiply this out, because then you're just going to have to factorize again. Is it equal to 0? Yes. Has this been factorized? Yes. So if I have two factors multiplied to give me 0, one of them has to be 0. So either x must be 0, or the second factor, x plus 3, must be 0. So either x must be 0, or x must be minus 3. It's the only way you could have two factors multiplied to give you 0 is if one or the other are 0. Now, most people will multiply this out when they see it, not realizing that it's already factorized. So think before you do things in equations. So that was a simple example to get us going. Let's look at this guy. It's a quadratic because there's an x squared. So I get everything equal to 0, which has been done for me. I then factorize. When I factorize, first thing I check for is a highest common factor. Do I have a highest common factor in this example? Yes, it's 2. So I get x squared minus 2x minus 3 equal to 0. Now, this 2 out front here, it confuses a lot of people. So often if I have a constant outside a bracket, I think to myself, could I not just divide by 2 on both sides? Could I not just divide by 2 on this side in an equation? What you do to one side, you do to the other side. Now that'll be great, because then my 2's cancel and it's no longer confusing me. And what's 0 divided by 2? 0. So often I will drop those, I will divide by that constant. I never divide by a letter, but I can divide by a constant on both sides, just to make my life easier. Now I still need to factorize some more, because I need to get two factors multiplied together to give me 0. So this is a trinomial. It's definitely x and x. The only way I can get 3 is 3 and 1. So I'm going to have minus 3 and plus 1. Let me check. Always check your factorizing. X squared minus 3x plus x minus 3. Absolutely. Now, if I have two factors multiplied together to give me 0, I'm ready to write my answers. Therefore, either the first factor must be 0, or the second factor must be 0, which gives me either x must be minus 1, or x must be 3. And in an exam, I would go and substitute those answers back into my equation just to check. So I would substitute x is equal to 3 and check, and I would substitute x is equal to minus 1 and check. Just don't be confused by a constant highest common factor. You can always divide by it on both sides. Right, let's try another one. This is only more complicated because it's not equal to 0. It is a quadratic, so I know my approach is get one side equal to 0. So I'm going to minus 13x on both sides. Now, as soon as I write down that, I forgot my x, I know that my order seems funny. Normally in trinomials, I have x squares, then x's, and then numbers. So immediately before I factorize, I'm going to swap those two numbers around just to make my factorizing a bit easier. Now, this is not an easy factorizing because 6 can either be 2 times 3 or it could be 6 times 1. And 6 can also be 6 times 1 or 2 times 3. So either I've got those combinations of factors, or I could have 2 and 3 and 6 and 1, or I could have 6 and 1 for the first 6 and 2 and 3, or I could have 6 and 1 and 6 and 1. So this is quite complicated. There's 4 different ways to do this. Now let's just have a look. If I had 6x and x, that would give me my 6x squared. The question is, do I choose 2 and 3 for those two, or do I choose 6 and 1? Because I've got to get 13x. Now, if I choose 6 and 1, I'm going to be getting very high numbers, because when I multiply these two together, I'm going to be getting 36x. So that seems very far off. So that seems quite unlikely. Let's think about 6 and 1 and 2 and 3. How could I get 13? If I put 6 and I put the 2 here, that would give me 12x. And I put the 3 here, that would give me 3x. Now, 12x and 3x are not going to give me 13x. Okay, what happens if we put the 3 here and the 2 there? So 6 times 3 would be 18x minus 2x. That gives me 16x. So that's not seeming likely. So I'm going to start again and say to myself, right, what happens if we used 3x and 2x? So how could I get 13x? Well, if I put 6 and 1, that would give me 18x and 2x again, which we've already been through. That doesn't seem possible. What about the 2 and the 3 and the 2 and the 3? What happens if I put a 3 here and a 2 there? Could that give me 13x? Well, 3 times 3 would be 9x, and 2 times 2 would be 4x, which could give me 13x. Now, it needs to be negative 13x. So it must be minus and minus. Now, let me check. 6x squared, yes. Minus 9x minus 4x is minus 13x. Minus times minus would be plus 6. So I've got two factors multiplied together to give me 0, which means either the first factor must be 0 or the second factor must be 0. So this is simple linear equation. I plus 2 to both sides, and I divide by 3 on both sides. Or I plus 3 to both sides, and I divide by 2. So I've got two separate answers. The difficult thing is you need to practice your factorizing in order to get these questions right. Okay, let's try another one. Let's try this example. Now, this example looks very interesting because this is definitely not a quadratic. Now, there's nothing stopping us from giving you a question like this because you can apply the same thinking. This is called a cubic equation because I can clearly see it's got an x cubed. Well, what's my process with quadratics? My process is get one side equal to 0. Done. What's my next step? Factorizing. I can factorize a common x, which leaves me with x squared minus 4. Can I factorize some more? Yes, it's a difference of two squares. X minus 2, x plus 2. Now, this is very different. I now have 3 factors multiplied together to give me 0. Not a problem. If you have 3 factors multiplied together to give you 0, one of them must be 0. So either x must be 0, or x minus 2 must be 0, or x plus 2 must be 0, which means x could be 2, or x could be minus 2, or x could be 0, and I have 3 different answers. So actually, we can use this logic to go further. The only problem is it's quite hard to factorize cubics. This one was quite nice because there was a common x. Right, let's look at example 5. Now, I chose example 5 to show you what most people like to do, and it becomes a bit tricky. Lots of people think, oh, look, something squared. Well, I can undo squaring. What's the inverse operation of squaring? And the answer is square rooting. If I square root x plus 7 squared, squaring and square rooting are inverse operations. So I will land up with x plus 7. So lots of people think, well, if you can square root one side, you can square root the other side, which is absolutely, that's a very valid point. And the square root of 1 is 1, so I'm minus 7 from both sides, and I get minus 6. Now that looks almost mathematically perfect. Why can't you do the same thing to both sides of an equation? You can. So what went wrong? And why do I say there's something wrong? Well, this is a quadratic because there's a squared. But why is there only one answer? Every single quadratic has to have two answers, which means something's wrong. Now, what's gone wrong here is actually there's nothing too bad with this logic. The only problem is it's the positive or the negative square root of 1. The square root of 1 has two different answers. It's positive 1, or the square root of 1 could also be negative 1. And if you forget that, you lose the second solution, which minus 7 from both sides would be minus 8. If you remember this positive negative square root thing, there's nothing wrong with this method. The only problem is most people forget. So how would I do this equation so as not to make any mistakes? Well, if I want to be more thorough, why don't I square x plus 7 and solve it like I would a normal quadratic equation? So I can multiply out x squared plus 7x plus 7x plus 49 equals 1. Rules of quadratic equations say get everything to one side, so x squared plus 14x minus 1, so this actually becomes 48 equals 0. As long as I've got everything equal to 0, factorize. Products of factors of 48 are 6 and 8. Can 6 and 8 give me 14? They can. So plus 6 plus 8. I'm doing this quite fast because hopefully we're getting good at our factorizing. Check. X squared, tick. 6x and 8x will give me 14x and 48, which means I have two factors multiplied together to give me 0. So either x plus 8 must be 0 or x plus 6 must be 0, which gives me x is negative 8 or x is negative 6. Now, if you remember from the other method, I did get those two answers if I remembered the plus or minus square root. So if you remember the plus or minus square root, you can use the first method. But if you're going to forget that, rather go back to basics. Right, one more example. This example looks slightly more complicated, but not really. I can just multiply out, collect up like terms, and carry on going as I normally would. So x minus 1 squared is relatively easy. It's x minus 1, x minus 1. And then I have x minus 1 and x plus 1 equals 0. Now these are two separate terms, so simplify each term. X squared minus x plus 1 plus x squared plus x minus 1. Great, it's a simple quadratic equation. Collect up like terms and then factorize. So x squared plus x squared gives me 2x squared minus 1x. Minus 1x is minus 2x's. And plus x minus x cancel. So I've got minus 2x. And plus 1 minus 1 cancels, which means I get 2x squared minus 2x equals 0, which is relatively simple. I'm going to factorize out a 2 and an x. So I get x minus 1. So I have two things multiplied together to give me 0. So either 2x must be 0 or x minus 1 must be 0. Divide by 2 on both sides. Gives me x is 0 or x is 1. And in an exam, I would go and check both of those solutions to make sure I'm right. Now, I would take down these three examples and practice each of these quadratic equations. Don't forget that with a quadratic equation, you get one side equal to 0, you factorize, and then you say to yourself, well, if two factors multiply together, it gives me 0, one of them must be 0. So pause this video and write down those three examples and practice. Good luck.